So following on from the previous two videos, I gave you this example, and then I also gave you this example. So here I'm going to give you another one here. So suppose you're given a function here, f of x equals this thing here, and you're told that x can be any number on the real number line, and also x cannot be 2, because if you put 2 into this thing here, you're going to have 1 over 0, because 2 take away 2, and then here in maths you can't have anything divided by 0. 0 cannot be at the bottom. So if you try and put 2 in here, the whole thing breaks down. So we deliberately specify that this thing here x cannot be equal to 2. Sometimes you're not given this here. So sometimes you're just told that, oh, a function f of x equals 1 over x minus 2, and x cannot be 2. That's all that you're given. Sometimes, in which case you have to assume that you can choose any number on the real number line. Okay. Well, and what I mean by a real number line is, if you look at your number line 0 here, and you can select anything on this line here. So negative 2, negative 3. You can select any number here. The reason why we specify real is because when you're older, you would do what's called complex numbers, and then it will extend upwards here. So you cannot choose a number that's up here or over here. Okay, you have to choose a number where it lies on this line, on this real number line. And don't worry about this complex thing, because it's quite complex and it's for when you're older. Okay, so you're given this function here. Well, I've done a whole section on sketching graphs. When you get given this function here, you can guess what the graph would look like. So hang on, let's try and draw this. So here, so here's something weird happens at well, looking at this here, this thing is a bit like a graph of y equals 1 over x. Now, when you get given a graph of 1 over x, it's like this. It's a reciprocal graph like this. Oops, like this. Okay, but here, well, just bear that in mind. The minute you see something like this, it's quite similar to 1 over x. Okay, but the thing is, something weird happens at 2 when x equals 2. So when you come to sketch this here, something weird happens at 2. So just bear that in mind. Something weird happens at 2. Now, if you so what you do is you select a number that's really close to the number 2, but just to the right. So you would put something like this: 2.00001 into this thing here, into this x here. Okay, so now 2.0001 take away 2, so that will give you 1 divided by 0.00000 whatever 1. So when you divide by a number that's really small, this whole thing here gets really big. If you don't believe me, get your calculator. 1 divided by a really small number, the overall thing will be really big. So you know, so you know your graph will be really high up here. Really, well, as it turns out, it's going to be really high. And then if you choose now, if you choose a number that's really far to the right here, let's choose 9999999 and so on. If you put 9999 whatever into here, it will, this bottom number here will be big. This number 2, yes, you will take away 2, but it would be 999999999. Take away 2, that will be 997. Okay, but my point is that this number here it will still be big. So now when you choose a number that's really big, this overall thing here will be 1 divided by a really big number. Now, when 1 divided by a really big number, it's going to be really small. So when x is big, it's going to be really small. And as it turns out, the graph will look something like this. Okay. Now you can then use the same technique on well, you know, something weird happens at 2. So you select a number that's really close to the 2, but to the left, just to the left of it. So you select a number that's really close to 2. Let's say 1.999999999 and so on, and put this number here, because 1.99999 is going to be around here, and then you put this into here. Okay, and well, I've done the whole section on this. This whole thing here will be minus 0.00000. It's going to be a really small number, and then as it turns out, well, if you have 1 over negative 0.00000 and so on, you move the minus up here. Okay, and then you take the minus out here, and then this whole number here, it will be a really big number, this whole thing here, but then it will be a negatively large big number, so your graph will look something like this. Okay, well, I've done a section on how to draw graphs. So as it turns out, this function here, if you don't understand this, then maybe watch one of the other playlists, or you can just get a graph plotter and plot this graph here. Well, it would turn out to be something like this. The number 2's here, okay, because you know something weird happens when you put 2 into here. And then if you put a number really close to the 2, but to the right, it's really high up. And it's really high up. And when you put a really big number over here, it's really small. So as it turns out, your graph will look something like this, okay? And use the same technique, but put a number that's really close to the 2, but just to the left of 2, and your graph will look like this. Okay, so your graph, hang on, let me just draw it again. So your graph will look something like this. It will look like this, and this number here is 2. Okay, now looking at this here, well, looking at this here, you can see that you can't put the number 2 in. Well, the number 2 is not in a domain. So this here is just another way of looking at the whole situation here. Okay, so your domain can be anything. Well, your domain here can be anything in the real number line. Okay, but you see 2, 2 is not in your domain. You cannot put 2 into this function here. So your number 2 itself will be out here. Okay, it's not in the domain. It's not in the domain. And your range, look, when we drew the graph earlier, hang on, let me draw the graph. Hang on, the graph looks something like this here. Okay, and this is 2. Your range can be anything in the real number line, because the range is what hits the y-axis. Okay, so it's everything here except from the number 0 itself. So maybe 0 would be out here. So this is just another way of looking at it. Okay, so I guess your range, you can write your range equals, well, it can be, well, it starts at, well, minus infinity, and then comma infinity. Okay, and it has to be curly brackets. Every time you use infinity, it has to be curly brackets. And here's a new notation here. You backslash, and then curly bracket, and then whatever you want to exclude in here. Here we want to exclude the number 0, because you can never get 0. This thing here can never get 0. You will not get 0 here. So this thing here means exclude, and then exclude the 0. Don't worry about this bit if you don't understand this bit. We will seldom need this bit. Okay. So anyway, that's it.